Hello students, as you learned about quantum numbers in the previous video, let us discuss some of the text exercise question related to quantum numbers. The first question which we are going to discuss is, first let us discuss question number 24, that is text exercise question number 24. What is the lowest value of n that allows g orbitals to exist? That means you have to mention the lowest value of n. N is the principal quantum number that allows g orbital to exist. As you have learned, orbitals are of s, p, d, f. So, you have to answer that g orbital will exist in which lowest value of n. So, look at this chart. This we have already discussed a chart that shells or the orbits are represented as capital K, L, M, N and so on, where the principal quantum number for K shell is equal to 1, 2 for L, 3 for M and 4 for N. So, if we consider the next shell, that will be n equal to 5. The next shell will be n equal to 5. That means outer to the fourth shell will be a fifth shell. So, as we have discussed this chart, that is, here for n equal to 1, there is in the first shell there is only one orbital. In the second there is s, 2s and 2p. In the third there is 3s, 3p, 3d. Fourth 4s, 4p, 4d, 4f. So these all are the possible subshells found in the first shell, that is 1s, in the second it is 2s, 2p, in the third 3s, 3p, 3d, in the fourth 4s, 4p, 4d, 4f. So after f only g will comes. So definitely when you look at the chart, s start with first, p start with the s start with the first, p start with second and the D start with third, F start with the fourth. So the possibility of G will be in the next, that is n equal to 5. So the G will start from the next shell, that is the n equal to 5. So what is the answer for this question? That means the n equal to 5 is the lowest value of n that allows the g orbital, because when you check the series, first s start with first, p start with the second, d start with third, f start with fourth. So definitely g will start with the fifth. So 5g will be found in the fifth shell. So let us check the answer for this question. So the answer is the lowest value of n that allows g orbital to exist, that is n equal to 5, where L will be equal to 4, because L for F is equal to 3. Therefore, L, that is the value for this will be, for g will be equal to 4. So what is our answer here? N equal to 5. Next question, that is question number 25th. An electron is in one of the 3D orbitals. Give the possible values of n, l, ml for this electron. That means there is one electron in the 3D orbital. You have to specify its quantum numbers, that is n. N is the principal quantum number, L is the azimuthal quantum number and ml is the magnetic quantum number for this electron. So let us do this problem. As 3D shows that 3 is the principal quantum number. So always whenever a orbital is given 3D, so there 3 means that is the principal quantum number. So the value of n is equal to 3. Now we need to find out L, that is the azimuthal quantum number. For this you need to check this chart. For S, the value of L is equal to 0. For P, it is equal to 1. For D, equal to 2. F equal to 3. This is the series which we have already discussed. So when you compare these, what you will get that for D orbital, because we need to answer for D. For D orbital, the value of L is equal to 2. So we got this value L equal to 2. Now you have to find out ml. ml, how we find it out? That is a magnetic quantum number. Because for 3D, as we discussed already, for 3D we need to make 5 boxes because of 5 orientation. Let us make 5 boxes for this. So when we make 5 boxes for this, that is each represented each orbital here. So the first orbital, that is a box which I am making here, it is represented, that is it is -2. The second one is -1, third one is 0, next fourth one +1, and fifth one is +2. So because in the question it is not specified that the electron is in which orbital, it was saying 3D. So 3D is a subshell. So the possible values that maybe the electron will be in -2, it can be in -1, it can be in 0 or 1 or 2. So the possible values of ml are -1, -2, -1, 0, +1, +2. So we got the answer, that is n is equal to 3 because it is given 3D. Next, L is equal to 2 because in the series when you find in the table for D orbital, the value of L is equal to 2. Next, the magnetic quantum numbers. For that case, you need to make the boxes, and because that is not specified, so you can write that possible values are -2, -1, 0, +1, +2. So in this way we got the answer for N, L and ml for the electron which is there in one of the 3D orbitals. It can be in any of the 1 3D orbitals. Next question, question number 29. Using SPD notation, describe the orbital with the following quantum numbers. Here 4 options are given, A, B, C, D. For each you need to find out, you have to describe the orbital and the quantum numbers are given as following. So let us do this problem. N, first one, n equal to 1, L equal to 0, where n is the principal quantum number and L is the azimuthal quantum number. So when you do for the first case, that is for the A case, if it is given n is equal to 1, means when we are writing an orbital, we'll write 1, L equal to 0. When L equal to 0, the value, that means it will be S orbital, so we can write 1s. So how we describe this orbital? On the basis of the quantum number n equal to 1, L equal to 0, that is 1s. So 1s is the answer. Next case, n equal to 3 and L equal to 1 is given in the question. So if the principal quantum number is 3, so we'll write 3, L equal to 1. So look at here in the chart, If L is equal to 1, then it is P. So we have to write 3P. So the answer for this is 3P orbital. Next one. If N is equal to given 4, so we need to write 4 and L equal to 2. If L is equal to 2, that means D. So we need to write D. Next one. N is equal to 4 and L equal to 3 is given. So principal quantum number, we always write that number. Then L. L represent the subshell. L is equal to 3 means the subshell is F. So we need to write F. So the orbital is 4F. So in this way you can do the question. So if you know the value of L, if it is 0 it represents S. If it is 1 it represents P. If it is 2 it represents D. And if it is 3 it represents F. So on the basis of this chart you can find it out L. And as we know that the principal quantum number, that numbers are written in front of the orbital. If it is 1s, means 1 is the principal quantum number. If it is 2s, 2 is the principal quantum number. That means the principal quantum number represents the shells, or we can say orbits, or the energy levels. So these are the answers for first case, it is 1s. Second case, it is 3p. For third case, 4d. And the last one is 4f is the answer. Next question. Explain, giving the reason, which of the following set of quantum numbers are not possible. Here some set of quantum numbers are given and we have to answer that which of the quantum numbers are possible, which is not possible. And we have to give reason for this also. So let us do the first one. The first one, n equal to 0. N is equal to 0 means the principal quantum number is 0. Then L equal to 0. The value of L, that is for s orbital equal to 0, for p is equal to 1, for d is equal to 2, and for f is equal to 3. So L equal to 0 means it is S. So write S. When you look at this one, 0s is not at all possible because the principal quantum numbers start with the n equal to 1. That means first shell, that is K shell, the value of n is equal to 1. So 0 is not at all possible quantum numbers, that is principal quantum number. So we can say that the first one is not possible because n equal to 0, that means first the principal quantum number 0 is not possible. Principal quantum number 0 is not possible. Second one, n is equal to 1 is given. So 1, L equal to 0. L equal to 0, as we have written already, S. For S, L is equal to, the value of L is equal to 0. Therefore, we can write S. ML 0. If L is equal to 0, ML can be equal to 0. So, that is also possible. Third one, N is equal to 1. So, we will be writing 1. L is equal to 1. L is equal to 1 means that is P. For S, it is equal to 0. For P, it is equal to 1. And ML equal to 0. That is also possible. So, if L value is equal to 1, then possible value of ML are -1, 0 and +1. So, that means 0 is possible. And MS value, that is spin quantum number, is +12. Okay, possible value. So, we can say that this is a possible value. Is it possible value? No, because if in the case of first shell there is no P, because first shell there is only one S. P start with the second shell. So we can say that this is not a possible value. So this value is not possible because 1p is not at all possible, because 1p means the first shell having p orbital, but in the first shell there is only one s orbital. So we can say that is not possible set of quantum numbers. Next one that is n equal to 2, L equal to 1, ML equal to 0 and MS value is minus half. N is equal to 2, that means 2. L is equal to 1. L equal to 1 means that is for S it equal to 0. For P it is equal to 1, that means it is 2P. ML equal to 0. So if L is equal to 0, ML 0 is possible. What are the possible values of ML? That is minus 1, 0, plus 1. So we can say that 0 is possible. And MS value, this is possible. So 2p orbital is existing. That is in the second shell 2p orbital is exist. So we can say that this is a possible value. Next one, the E1. N is equal to 3. L is equal to N equal to 3, L equal to 3 and ML is equal to minus 3. MS is equal to plus half. So N equal to 3 means 3 is the principal quantum number. L value is 3. For S it is 0. For P 1. For D 2. And for F it is 3. So value of L is given as 3. That means it is F. And we know that 3F is not at all possible, because in the third shell there is 3S, 3P and 3D. That means F is not possible case. So we can say that the E part is not possible. Next, the F part. In this, the value of N is equal to 3, value of L equal to 1, ML is equal to 0 and MS is equal to plus half. So let us check the orbital for this. N equal to 3 means 3 is the principal quantum number. L equal to 1 means for S it is equal to 0 and for P it is equal to 1. That means L is equal to 1 is given, that means P orbital. So we need to write P. ML is given as 0. If L is equal to 0, then the possible values of ML are, if L is equal to 1, then the possible values of ML are minus 1, 0 and plus 1. So that means ML equal to 0 is possible. And the spin positive half, that is also possible. So we can say that this is a possible orbital. That means possible set of quantum numbers. So from this we concluded that for the first case it is not possible because N value, that is principal quantum number, it can never be 0. So first one is not possible. Second one is a possible value. Third one, in the third one the value of L is equal to 1 and N equal to 1. That means 1p. And 1p is not possible. In the first shell only 1s is present. Therefore this is also not possible. So first one is not possible. Second one is possible. Third one is not possible. Fourth one is possible. All set of quantum numbers are possible values. E part is not possible because in this case L is equal to given 3. L equal to given 3 and that means it is 3F. And 3F is not possible because in the third shell only S, P and D are there. F is not present. So this is not possible. F1 is a possible set of contour numbers. So this is the answer for these questions.